So now let's summarize how we deal with different situations in our strong acid, strong base titration. Remember, at all times, the first thing you want to do is find out where you're at in your titration curve. How you do that is by finding the number of moles of acid that you have and the number of moles of base, and then comparing the two. So in the beginning, when we have added no base, the pH is found directly from the concentration of our strong acid. You just plug it into your pH equation. So here on our graph, that is our starting point. If I'm in between my starting point and my equivalence point, that means that the number of moles of acid that we started with is greater than the number of moles of base that we have added. When this is true, we subtract the number of moles of hydroxide that we've added away from the number of moles of hydronium that we had initially to find the number of moles of hydronium remaining. Then we divide by the Vtotal to find our concentration of hydronium, and then we find the pH from that. When we're at the equivalence point, so that's right here on our titration curve, we understand that the pH is equal to 7. The equivalence point means that the number of moles of acid that we start with is equal to the number of moles of base that we've added during this titration. So there's no mathematical way of coming up with this. We just know that the pH is equal to 7, and the reason why this is because there's water in solution. So we cannot have a zero concentration of hydronium. When we are past the equivalence point, so by that it means that the number of moles of hydroxide that we've added is actually greater than the number of moles of hydronium we started with. Now we're interested in how many moles of hydroxide we have left over. So you take the number of moles of hydroxide that you added during this titration and subtract the number of moles of hydronium that you started with, and from that you find the number of moles of hydroxide remaining. Then you divide by Vtotal to find the concentration of hydroxide. From that you find the POH, and then from that you find the pH. So you can see here after the equivalence point the pH still climbs quite drastically.